Hello, hello. Welcome to Switch 2020 and our event Innovation Made Real Alternative Protein Future Food. I am JI, Ecosystem Developer at NUS Enterprise, your host for today. NUS Enterprise is the entrepreneur arm of the National University of Singapore, where we advance innovation and entrepreneurship at Asia's leading university. Today, we're super stoked to welcome you to this session on cultured meat, following the heels of a historic announcement by Singapore, the first country in the world to extend regulatory approval for cultured meat. So today in this session, we will hear from our distinguished guests who are innovators at the forefront of this revolution. We have with us today Prof. Jan Ajali, Chief Science Officer with TechCo. Also, Vinayak Srivinas, co-founder of Gear Foods, Mihir Prashad, co-founder and CEO of Umami Meats, and Shujian Ong, co-founder and R&D director at Ants Innovate. We are very happy to also have our moderator for this session, Dr. Matthew Zhao, food scientist from Big Ideas Ventures. For this session today, I'll first invite each panelist to give a short 10 to 15 minutes presentation and hand over the session to Matthew for Q&A. If you have any questions at any point in time, please feel free to put them below in the Q&A function. We will address them at the end of the session. So without much ado, let me invite Prof to share your slides. Prof. Jan Ajali, please. Prof, I think you are muted.
Right, I share my slides.
Yes, please. Thank you.
Okay. All right, thank you, GI, and thank you for inviting to this interesting and excited meeting. So I'm going to talk about, so it's in the end, so let me go back to the first slide. So we are going to talk about today Biftec, our company that are in the ecosystem of cultivated meat. So we all know actually the meat is delicious, but it has a very heavy impact on the humanity. So it uses lots of waters, uses lots of lands, and emits lots of carbon dioxide, and also used lots of antibiotics for these animals not to get sick for their economic reasons. So the solution for this is the cultured meat or cultivated meat. So it is a real, and it is better. It uses less resources, uses less resources in terms of water, land, and emits very little amount of carbon dioxide. And these are the very important for the earth. And also it's free from GMO. It's free from contamination. There is no problem of antibiotic resistance, and there is no you don't need to see the very terrible things from the slaughterhouses. So the animal welfare obviously much better in the cultivated meat area. But it is something that the formation of the muscle cells, the cultivated meat, is not difficult to do it. So you can differentiate the muscle cells from the stem cells, muscle stem cells, which we are also using this technology. But the problem is the cost to become a commercialized entity. So the cost, as we all know, the initial burger in 2013 was cost like more than $300,000. The reason for this is because of the conventional, in the conventional culture, you have to use fertile bovine serum, which is the source of the growth factors to grow and differentiate those stem cells into the muscle cells. So almost, or maybe more than 90% of the cost of producing myocytes from the muscle stem cells are coming from FPS. So the cost has to be lower if you want for cultivated meat to become available for the whole world and to take advantage of using cultivated for the humanity. So our company, Biftec Co. So our solution is we grow, we set up and we generate a growth medium supplement instead of using FBS, which is what we call Biftec growth medium supplement, and we have filed a patent for this, and it changed it radically changed the production paradigm and caused the cost considerable. Now, these are our solution based on plants and the microorganisms. We don't need animal for this. It's animal independent. It's GMO free. It's natural, and it costs the price considerably. So there are other companies also in this area that we are in this generating of the generation of this culture media supplement. However, we are different from the other ones in two ways. One of them is we are natural. We don't use genetically engineered methods in order to produce growth factors. So therefore, it is very cost effective and natural. And this is our difference in terms of when we compare to the other companies. So why we are, or what is our difference? So we use, and I'm going to show you, so this is the technical part of my talk. We use what we call beneficiary microorganisms from different species. We are using their postbiotics as a source for growth factors to grow these cells instead of FPS. So it brings the cost per liter of FPS of approximately $400 to only a couple of dollars. And we also analyze at the end of our production. We also analyze the content of these postbiotics for primary cells as well as the cell lines to understand what is the factor that is important for the cell growth in the myocyte development. So with our technically with our patent pending methodology, we take advantage of, as it's written here, to produce and use the lyophilized cell-free extracts, which are the postbiotic mediators from the beneficial microorganisms that we isolated from natural microbiota to stimulate cellular proliferation during cell culture. Our product is natural and low-cost alternative to FBS, and the product is delivered in lyophilized powder formulation, which easily dissolves in water or growth medium without no problem, and you can use it directly in the cell culture setups. The product also preserves its functional properties in production, transportation, storage, and application processes. So these are something that we are trying to more optimize these conditions. Maybe one of the most important aspects of our product is, since we use those metabolites from the bacteria, from the microorganisms, we obtain the same ratios as long as the fermentations conditions are the same, which is part of our pending patent application. Therefore, there is no concern for sustainability and for problem for the batch-to-batch variation of our product. So what is postbiotics? So postbiotics are also known as metabiotics or biogenics or simply metabolites. They are soluble factors, which is secreted by the live bacteria or released after the releases of these bacteria, and that is a tremendous physiological benefits to the host in normal life. We all know probiotics. Probiotics is full of these with the yogurts and other kind of material that we consume every day. But now this time is we are using the postbiotics of these bacteria or these microorganisms to take advantage of using of their growth factors, the growth factors that they are providing for us. Postbiotics it has a high target and specificity. It's bioavailable highly. There is no risk of injection, and there is no risk of antibiotic resistance, and there is no risk of interference. So you can control very easily these postbiotics for the use. Now, our technical scheme is something like this. So we have a library of more than 200 different sources. And we, first of all, screen, and this is our patent pending conditions by using these different microorganisms and the products. And we obtain these postbiotics, and these postbiotics then, with these postbiotics, we test it in the in vitro experiments as well as ex vivo experiments. And we are in the process of looking for investment to scale up this procedure when we know these growth factors. we know their structures, and with scaling up, we would be able to use it after scaling up the postbiotics for the use of for the consumption. So what are the postbiotics? So there are 7 different postbiotics from the bioactive components produced by these beneficial bacteria. And in our list, we use, out of these 7, we use these 5 of these factors. So we know what are the factors that have effect on these, on the growth on the growth of these muscle cells. Now, there are 2 slides here that shows the nowadays nothing related to the muscle growth, but this one. But these postbiotics is being used. Different postbiotics have been used and published using in different conditions, metabolism to heart disease, cancer, as an immunostimulant, neurodegeneration, as well as obesity. The different kind of these postbiotics have proven effect on the different functions. So what we think is that should be true for the muscle growth also. And when you look at the literature, you can see that in the literature, you can see that the effect of microbiota in the muscle cells, and they specifically affect the mitochondria of the muscle fibers and act on the glucose uptake as well as protein synthesis. So therefore, there is a room to ask whether or not these postbiotics have effect on the muscle growth from the muscle stem cells and proliferate these cells to become a muscle tissue. So literally, I mean, there are many studies related, the molecular studies that shows the effect on the muscle fiber. These are the molecular mechanism that cause these postbiotics that has effect on the skeletal muscles. Both the postbiotics, in this case, this is the short chain fatty acids, and as well as the vitamin D may have effect on this. So the problem is, or the condition, what we are trying to do is we are trying to produce these postbiotics in a very cost-effective way. We tried it with our, we use it in our lab. We use in different cells from different origins, and these are the names for our groups, and we use more than 6 of them. Some of them, as you can see, and the one that you see on the right-hand corner is the way how we grow these cells with the FPS, and many of them has similar. And in the other groups, we don't use any FPS. But even though if we don't use the FPS, they have almost, as good as FPS, in some conditions, much better than, as you see it here, different postbiotics have much better cell growth, cell proliferation rate than the FPS itself. So that is very, and we have repeated these experiments. We do this in different cells. As I said, we use different cells of different origins, and we saw it's a dose dependent. We can test it. And this is different postbiotics are very promising results for conditions for muscle cell growth from the muscle stem cells. So the topic of this talk is the hype. It's a hype or the feature. I think it's the feature. It's not a hype anymore, because some of the other companies in this area, in BIFTEC, what we do is in our company, we take a biopsy from the animal. We isolate the stem cells, muscle stem cells out of this biopsy, and then grow in the absence of FPS, but in the presence of these postbiotics that we formulated and applied for the patent for the production. So this is going to be the future. This should be the future if you want to, because it has a potential to reduce the environmental cost, because it increases the health benefits for humans, as well as it protects the welfare of the animals. So it has to be the future, and that is what we are trying to understand. We are 4 founders in BIFTEC, including myself and 3 others from the science, finance, and the business, and we have been advised by very experienced advisors in terms of business and the financing of our products. And I thank you for listening my talk, and I'd like you to join us to make this culture meet affordable. Thank you very much. I think it's less than 15.
No worries. Thank you very much, Prof. I think replacing FBS with something more sustainable that will truly make cultured meat sustainable. So let me invite the next panelist, Vin from Gaia Foods, to share his slides. Thanks, Vin.
Can you guys see my slide?
All good.
Okay, sure. Hi, everyone. Thank you for your time. Okay, so I'm Vinayaka. You can call me Vin. I'm the founder and CEO of Gaia Foods. 40% is actually the amount of red meat that is consumed by Asians, and it's a $500 billion industry. And if you ask how is red meat produced, it's actually produced in the most environmentally degrading manner. Actually, 37% of the global methane emission comes from animal farming, and we use like COVID has already clearly shown that this way of producing meat is not immune from any of the pandemics. And also we produce way more animal. We almost kill more than 72 billion animals every year to feed a population of 7 billion people. That's simply mind-boggling. I don't understand how we achieve this state, but that's the reality of situation. And luckily, we have a better way to produce meat, and this is known as cultivated or cell-based meat. As Prof mentioned earlier, here we take a small animal tissue from the living animal. We don't have to kill the animal, and we isolate stem cell from them. And we give them the best possible condition for them. Like we give them the best nutrients, food, and also environment for them to grow and thrive. And once they are achieving the critical mass, we harvest the meat and produce the meat of any choice. And if you look at the technology, it looks very simple, and you may be asking, oh, if this is so amazing, where are the companies and where are the products? There are several companies in this space working on producing cultured meat. Like there are companies in US and also in Middle East and Israel and all. But most of the companies' focus is producing mince meat or meat for Western audience. That is like they are producing beef patty and sausages and meatballs and things like that. But if you ask in Asia, when was the last time you ate sausage or beef meatball, you'll get a varied answer. So that's not the common food that is consumed in Asia. And that's where we come in. We are actually the Southeast Asia's first cultivated red meat company, and we are based in Singapore. This kind of gives us a unique understanding of different Asian food culture and food habits. And that helps us design products for Asian consumers. The whole point is we don't want Asia to be just we don't want to compromise on the food that we are eating with this technology. We want to give the option at the same time as everyone else. And that's why we focus our initial products to be for Asian consumers. And that's why we are based in Singapore. And how are we going to achieve this? And for any cell-based companies, there are three main factors. That is like taste, texture, and pricing. This is especially true in Asia compared to other countries, mainly because Asia is very, very price-sensitive market. And so if you don't give taste, people don't eat it. If it doesn't feel like meat, they don't eat it. And if it's not correctly priced, people don't eat it. So we have to address all these three things together. And that's where we are focusing on. So for taste, we are using animal cells. So this kind of gives us a unique advantage because we don't have to create animal type tasting meat. Because we are taking cells from the animal, we have the advantage like they retain certain amount of taste. And for texture, we are going to be using different scaffold materials that are locally sourced. Just to give an example, if you talk about soy protein or tofu in Asia, people don't feel anything novel or foreign about it. But when you talk about soya or tofu in countries, they have a unique, like it's a very foreign material for them. And our technology, what we are trying to do is we are kind of creating a platform for producing any textured meat. It doesn't matter. Like if you're in Asia, you can choose the local materials and design products based on that region. And the same thing, if you want to go to US, look for a material that are commonly used in US market and produce meat based on that scaffold material. So these are the ways we are trying to address the texture part of it. And for serum, that's, as Prof mentioned previously, this is one of the biggest cost contributor for any companies and growing cells. And we are approaching this from multiple angles. And one of the angle is through yeast fermentation method, because fermentation is a century-old technique, and people have shown and perfected the way in which we can grow and scale up the technology. So now what we have to find out is how do we use this technology, produce factors that are required for culturing cells at a cost-effective manner. And that's what we are also focusing on, how to bring down the cost and the serum-free media option. And till now, what we have managed is we have managed to isolate stem cells from animals, even though we are sitting in Singapore, which we are at a unique disadvantage because in Singapore, there are no animal farms. We can just go and pick up cells. So we really have to, this kind of access is one of the big barriers. And so we managed to isolate a non-genetically modified stem cell from beef and pork. And then we have already in the process of filing our provisional patent for our platform scaffold technology. So this is one of the major advantage we think we'll have going forward, because this gives us advantage for anyone to come in, like plug into the system. Like let's say if we go to Europe, hey, I want to produce a Iberian pig. So we can plug into our platform and our technology and think about producing meat that for that specific region. And we already within the span of like less than 1 year, we started our lab in 2019 December, and after 3 or 4 months we had to close down the lab, but then we are opened again. But within the short time period, we managed to reduce the cost of our culture media by 60%. This is just by tweaking the ingredients. We didn't really change any big thing, but just by tweaking the ingredients. So this gives us this kind of gives us a potential for us to like understand the scale. By optimizing certain things, we can achieve a significant amount of price reduction in this technology. And how did we manage to achieve all these things is mainly through the amazing team we have put together. Me and my co-founder both are stem cell scientists by training, and we both are trained locally, and we have idea about how to do certain challenges that are facing this industry. And on top of that, we have put together a team for media development and our cell line development. So with this, we are very confident about going forward as well. And going forward, what we are planning is within next 2 years, we want to remove the meat serum completely from the equation and reduce the cost significantly lower so that it can be marketed to the public. And then we will be focusing on scale up in a pilot scale manner, because large scale up requires a much significant amount of investment, but pilot scale up will give a proof of concept for us to go to the market. And exactly we will use that idea to go to market locally in Singapore through premier restaurant crowd, so that early adopters and people who have idea about this technology can taste the meat and give us a critical feedback for us. That is absolutely important for us to design our product for going to local mass market launch and also throughout the world. And if you would like to know more or understand the technology, in-depth technology behind us, please feel free to contact us any of this channel. We are sitting in Singapore. We have offices in NUS and also in A-Star. We are happy to catch up and discuss further. Just contact us for any information you need. We'll be happy to talk. Thanks a lot for your time, and hope to answer any questions if you have. Thank you.
Thanks, Vin, for sharing on your work on sustainable cell-based red meat. Next up, we'll have Mihir Prasad, who'll be talking to you about sustainable seafood without the sacrifice. Over to you, Vin. Mihir.
Thank you. Okay, can you see my screen?
Yes, we can see it.
Perfect. Good afternoon, and look forward to talking with you today about umami meats and the work we're doing to make seafood sustainable for consumption in the long term without sacrificing our oceans, our health, and the amazing biodiversity that we have on our planet. So we envision a world in where we can consume healthy, sustainable seafood, as I mentioned, without having to sacrifice animals, our ocean, or our planet. And to that end, our focus is on developing low-cost serum-free media as well as marine cell lines that will enable cost competitive cultured meat and especially seafood production at scale. And the reason for this focus is personal to our founding team, but we are avid supporters of marine sports and of the oceans, and think that really, if we look at what needs to happen for seafood to be sustainable, it's become critical for us to solve this problem in a short period of time. And what we'll say is that basically seafood supply cannot meet the growing demand that we have, particularly in Asia Pacific, between now and 2050. So one of the biggest threats to the food security and the security of our oceans is climate change. Ocean acidification, as well as temperature increases, are threatening the natural habitats and ability to survival of many species, from fish to crustaceans and beyond. And if you add on to that increasing demand for seafood, leading to big farms, as well as bigger and bigger catches every year, we're running into a wall in terms of what we can produce without collapsing the ocean ecosystems. But when you pair that up with global protein demand growth over the next 30 years, we have to nearly increase by over 2/3. And that's a pretty stark contrast of what we can actually achieve versus what people want to eat. So for us, we say that the solution is to produce the enabling technologies for cultured seafood to come to market and help meet this demand growth before we overfish our oceans and put them in danger. And the number one hurdle to achieving cost competitive cultured meat and seafood is the media cost. And as you've heard in the Beef Tech presentation and echoed, and you'll probably hear echoed in all of our presentations, cell culture media is the number one cost. And within cell culture media, the growth factors make up almost 100% of that total cost. So really, while there are a number of things that need to be achieved to make cell cultured meat viable on the commercial market, the primary cost challenge comes down to reducing the cost of media. And current sources today include bovine serum, but also synthetic growth factors. Both of these are in effect 1,000 times too expensive for what we need to achieve. And so our solution is a supplement that can be added into a basal media for growing cells. And that supplement essentially enables growing cultured meat for 100 times less than is currently feasible using bovine serum. We have found a way to extract and produce a serum replacement that is rich in the amino acids cells need to grow, as well as the other proteins and factors that lead to robust cell growth. We harvest from a sustainable source. That means that we'll be able to scale it without putting additional pressures on our environment and our oceans. And we can scale our production with short lead times, making our ability to produce demand sensitive. So one of the really unique things we think about cultured meat is the ability to scale up and down the production of a meat to match supply or to match demand of consumers. So if somebody in a culture only eats a certain type of fish or a certain cut of meat in let's say December or Chinese New Year, there's an opportunity to actually match that so that supply becomes available for these events. And to do that, scalable production with short lead times is critical. And so the growth factors and the umami meat supplement we're developing is really the beginning of a platform for reducing cell culture media cost across the board. Once we commercialize this supplement, we can, as I mentioned, reduce the cost of cultured meat by about 100-fold. But there's still additional cost reductions that can be gained that will make cultured meat even more affordable going forward. The second is to actually reduce the amount of media that is required to grow cells. Now, the best way to do this is to actually, in parallel, develop cell lines that are optimized for your low-cost media, so that those cells you don't have to make unnecessary or unwanted changes to your media to get the cells to grow. So by doing that, you can actually reduce the total volume of media required to grow your cells and make your cells happy without having to sacrifice performance. And the third area of focus is around the basal media. And so this is the basic sugars and amino acids that cells need to grow. And today, most of that is sourced from pharmaceutical grade suppliers. And so pharmaceutical grade suppliers, because they have to meet a bunch of constraints related to the end product being put directly into a human bloodstream or into a drug, you end up with higher standards than are sometimes required for food. And so if we can, for example, take glucose and exchange that for food glucose that's already in many of the foods we eat, we can help reduce some of the cost even further and generally reduce the cost of media to the point that cultured meat can achieve price parity and eventually become cheaper than traditional meat. We see ourselves fitting into the ecosystem as a business-to-business technology provider. So we want to work with cultured meat companies to produce key inputs, namely serum replacement to help reduce their media cost, as well as cell lines that are optimized for production of seafood, and help to commercialize that work, and then contract with a manufacturer to produce that at scale to help achieve price parity and reach the market demand as quickly as possible. And the reason we think this is important is that the projections for how big cultured meat and seafood could become within all of our lifetimes are staggering. I think if we talked 5 years ago, very few people would project that cultured meat could achieve something like a third of total meat consumption by 2040. But numerous studies have projected that cultured meat could achieve these types of growth rates if the cost can come down enough to get consumers interested in purchasing. And to do that, technologies like ours will be needed to help drive this industry forward. So our goal is to make sustainable seafood and meat available without having to sacrifice our planet. We think that providing enabling technologies like a serum-free media and optimized edible cell lines to other companies is one of the best paths to do this as quickly as possible. If you're interested in learning more, please reach out via email, and look forward to taking your questions later in the event.
Thank you very much, Mihir. I look forward to discussing more as well. So last but certainly not least, we have Shu Jian to share more about cell-enhanced meat cuts. Over to you, Shu Jian.
Hello, everyone. My name is Shu Jian, co-founder of Innovate. I'm a recent graduate from NUS, where I studied life sciences and material engineering, and was an A-star scholar. I've worked on cultivated meat research for 3 years with Professor Henry Yu in A-star before co-founding Innovate together. I now lead the R&D of cultivated meats in the company. So Innovate is an A-star spin-off focusing on cultivated whole meat cuts. We design and manufacture cell-enhanced meat cuts to enable the complete meat eating experience for consumers. Right now, we are seeing a boom in alternative meats, and most products on the market right now are minced meats like burgers and sausages. We believe that Innovate's technology will push the industry towards the next frontier of alternative meat cuts. So perhaps to give a little background on the process of cultivated meat cut production. The concept of cultivated meats is based on tissue engineering principles, which now is used for growing artificial organs and tissues for medical uses. The process starts with obtaining a cell source from an animal. Usually this cell is a stem cell that can multiply when given the right growth medium that provides it with nutrition. The cells are then converted into tissues like muscles and fat in a process known as differentiation. The muscles are then turned into meat products after further food processing. We noticed that a lot of emphasis within the industry is placed on growing cells and lowering the cost of medium production. The thing is, we think that differentiation, turning cells into tissues, is not given as much attention. Cells by themselves are not meat. They do not have the right texture, and they need to be combined with a supporting structure known as scaffolds to give them the right texture, appearance, and mouthfeel that we consumers like. So that is what Ensinovate is focusing on, turning cells into tissues and into products that consumers love. So to truly understand the concept of cultivated meats, I think we need to understand what exactly is meat. A common narrative for cultivated meat is that unlike plant-based meat, it is going to be exactly the same as meat, down to the cellular and the biological scale, just because it's made from cells. So meat is actually a very complex tissue. It is made primarily from muscle, but also includes many other components like fat, connective tissue, and other cell types. For muscle, you have myosin heavy chain, you have the muscle fibers, you have connective tissue like the extracellular matrix, the proteoglycan. For fat, you have the adipocytes, the basement membrane, collagen, and other cell types like the blood vessels, blood, immune cells, and nerve tissues are all in meat. If we want to make meat that is exactly the same as what is from an animal, we think that is almost impossible to achieve. In fact, we think it is over-engineering and unnecessary for food production. So we think that we should be more focused in engineering meat. Meat is ultimately made for consumers. So instead of thinking about how biologically similar it is, it's more important to consider how the technology can bring value to the consumers. So if we were to break down what meat is to a consumer, I can identify 6 key attributes of meat. The first contact with meat is the appearance, such as the marbling and the stringiness of the meat when you tear it and bite into it. This can be provided by plant-based scaffolds and is already done quite well by plant-based meats. Next, when you bite into the meat, you can feel the texture and the mouthfeel, and these can also be provided by engineering scaffolds. As you chew it, you taste the umami flavors that can be provided by any source of amino acid like glutamate, which mainly sourced from plants. Lastly, we eat meat because we want the animal nutrition from it. In fact, plant-based proteins and fats have been formulated in plant-based meats to give you almost all the nutrition that you need. Amongst these attributes, most of them can be obtained from plants. The only exception is the rich and complex meat aroma that is provided from meat. So I think this is where we think cells will play an integral role in meat substitutes. So that is why our first product will be what we call a cell-enhanced meat snack. We have 2 products in development, a jerky-type meat snack and a meat cutlet. We made these using primarily plant-based fibers to provide the meaty texture and neutral taste. We then control its appearance with our patented natural color control technology to make it look like meat. We then add in our cultivated cells, in which we have developed a process to bring out its rich, meaty flavors. In this way, the cells only provide flavors that the plants can never provide, and we only require very little cells to create a commercially viable meat substitute with significant improvements over existing products. Our longer-term goal, which likely requires 1 to 2 years more, is to produce whole meat cuts like steak and pork belly. We analyze what defines a meat cut to guide our engineering approach. On the left, you can see here is a typical plant-based meat made from wheat gluten, which is a very common vegan ingredient. On the right is a piece of steak. The key difference is not really its size or its shape, but really the separation of strands after cooking, the strands of muscle fiber. To achieve this, the strands is really what separates plant-based meats from real meats. to let consumers experience the distinct and characteristic mouthfeel of meat. To achieve this, we are developing our tissue building block technology and our whole meat cut technology. How this works is that we grow meaty cells, the same as we are using in our meat snacks, and combine them with plant-based scaffolds to provide the appearance and the flavors of meat. But instead of forming them into a snack, like our first product, we form them into meat strands, meat fibers. The fibers are then bundled up into meat strands and eventually form into a steak, or chops, or pork chops, or fillet. So this is what is known as a bottom-up approach, with a key advantage of having high precision in structuring the meat, which will provide much better mouthfeel for consumers. So even though we think cells for the moment should serve as the flavoring agent, we still believe that one day cultivated meats can be made entirely from cells, but we think that there are many bottlenecks that need to be resolved with innovations from brilliant companies that have presented before me. And we think that we likely would not see a commercially viable products for the masses if we focus on purely cell-based meat. But perhaps in the future, we will see a fully cell-based meat. So thanks for listening, and please contact us if you would like to learn more about Innovate. Thank you.
Thank you very much, Shu Jian. That is very interesting perspective on using cell culture as a flavoring ingredient. So I can already see the questions streaming in for speakers. For the next section, let us invite Dr. Matthew Zhao, who will be leading the Q&A. Matthew is the food scientist at Bit Ideas Ventures, a VC firm which invests in future food tech in the alternative protein ecosystem. His technical expertise includes post-harvest technology, food packaging, processing, shelf life, and other novel technologies. So over to you, Matthew. May I also invite the rest of the speakers to come online?
Hi, thank you, CI, for giving this chance to be the moderator for these Q&A questions. Really excited to see 4 different amazing startup companies looking at different areas addressing the cell-based industry. And everyone has really done a lot of milestones to create a lot of different technology involving the scaffold, the growth factors, the growth media, and as well looking at different cell line. Probably let me start off with some couple of questions on my side, and then we'll roll over to the questions given by the audience. So anyone, if you do have questions, please remember to write it at the Q&A sectors, and then I will ask the questions to the 4 different startup companies. Let me start first by asking, I believe everyone has been going through a tough journey creating a technology that you have been working on. So I'd like to hear what sort of challenges that you have faced along the road, because I believe there's a lot of things that you have to go through regardless of the regulations, the technology, the innovations and stuff. So happy to hear what sort of challenges that you have faced. Probably I can ask John to start from BeefTech to give your opinion. So what sort of challenges that you have been facing so far?
Okay, thank you. So in terms of our research and the development, so once the first problem that, or the bottleneck that we need to overcome, is to be able to deal with the many very large volume of cells, so that in order to understand whether it has effect, our solution has an effect. And then we compare with the FBS also. So it's a tremendous workload for our scientists and people who work in the lab. So that is one thing, but this is once we have received. So when we first start, we mostly focus on the plants, but the plants, the bottleneck, possible bottleneck for the plants is, you still will need land to grow these plants, and that is also expensive. And if you want to commercialize it, you need a very large amount of area for this. So to calculate how much you need this land is it was very difficult for the plant. But then we, along with the plant, then we start working on considering these microorganisms or microbiota, because it's a very popular in science nowadays. And we found that, you don't need, so we think that for the problem of the land versus the cost will go further down. So we think that by using these microorganisms, we solve this bottleneck. But once we have accomplished this, the main problem is to be able to, first of all, like everyone's, to be able to find money to do this research. And the second one is to deal with this kind of large amount of cells that we use. So we mainly focus on the cell differentiation and the proliferation. So these are the main bottlenecks that we had previously.
Yeah, thank you for sharing. I think this is really a huge bottleneck to this, to really have to climb over to understand all these different categories. Probably I'll ask this question: what's your greatest challenge to Vin from Gaiaford? Happy to hear from you. What's your challenges along the way?
I think there are few challenges for all the cultivated meat space companies. And one is the cost. Currently, the cost is ridiculously high for anyone to even afford. So that's out of the question at this point in time. So that's why we really have to think about a hybrid product in the initial stage. As Shujian was mentioning, I don't think we will go for a fully cultured meat product in the initial stage, mainly because in order to go for a market, we have to think about hybrid product, which will give us some advantage in the pricing area. We'll go with that route, and by that time, we'll generate enough technology so that we can bring down the cost to a significant lower level. And that's one part of it. One of the biggest area we don't know, no company knows, is how do even consumer treat this product. We all think that we are all developing technology. We are thinking, oh, this is amazing, everything is good. But if at the end of the day, if consumers don't like it, I don't know, we have to think it. So that's why we have to go and educate each and every one of them and like explain the technology and what exactly we are doing, what are the advantages and disadvantages, and keep it as open as possible so that they feel more comfortable and confident about the technology. If we close up ourselves and give ourselves a lab company, lab-based and all, I think we'll be hurting ourselves in the long run and helping all of us. So any one of us, that's what I keep asking anyone, like if you, of course, we'll keep some proprietary information with us, but the fundamental technology, we will explain you to the maximum level for you to understand and believe that this is a fine technology. It's not like a very bad thing or anything. It's a pretty okay thing, and help us spread the message. That's the important thing. We don't know that factor yet. So we are hoping that people will accept the product in the future.
Yeah, definitely. I think acceptance and cost definitely plays a huge part in terms of looking at product development and acceptance. Probably beside this too, I would like to ask Mihir, what's your take on this? Looking at cost, looking at acceptability, what other challenges do you think that you have to overcome in order to be in this cell-based industry?
Yeah, so I think for the seafood sector in particular, there's a unique challenge of less data being available on how to actually culture the cells to start with. So in addition to having to figure out the right culture media, you also sometimes have to think about what temperature do they grow at, what salt concentration do they like, and it adds additional complications and variables to the very earliest work of just trying to get a cell line you can test on. And then I think beyond that, cost is, I think, not only a problem for the consumer side, but it also increases the cost of our R&D. So in some ways, driving down the cost of R&D is important, because if you run out of money before you get a commercial product out and you can actually be generating revenue, that's a significant barrier to actually getting anything useful done. But I think also the regulatory and consumer acceptance is something that actually plays a lot into the R&D, because it determines what kinds of approaches you can take. There are some very good approaches, for example, to making cells proliferate for long periods of time that a regulator may not like, because it involves using a technology that they would have a lot of safety questions about. or a consumer might not want anything considered transgenic, which then means you have to avoid many well-characterized approaches and perhaps pioneer a different approach. So I think trying to get clarity on these things early is very difficult because you don't know exactly what you're selling yet, but it's also impacting how you're driving your R&D forward. So it's a bit of a catch-22 that I think all of the companies in the industry have to face.
Yeah, definitely. I think regulatory is always one of the big issue to see how you can overcome this. Consumer acceptance as well have to always I really have to understand what sort of consumers looking for and how in the terms of the taste and nutritional aspects as well. I know recently, I think since last week, there's a lot of hypes about the SFA coming with the novel regulations having approved for the cell culture meat to be sold in Singapore. Sujin, I just want to ask you, what's your take on this? Do you feel motivated, or are you feel hyped up about all these regulatory issues that Singapore government is being very supportive to the cell-based industry?
Yeah, certainly. I think the first approval of the chicken nugget from Just will just pave the way for all of our other products to give us more confidence and certainty that our products will get regulatory approval as well. So for us at Innovate, we have been speaking to the Singapore Food Agency for quite a while to discuss the safety regulation of our cell lines. Throughout our discussion, it seems that the Singapore Food Agency wants to understand what we have so that they can use our cells in our products to set up their own regulatory framework. So there's a lot of back and forth discussion of us learning about what SFA wants and SFA learning about what we have. But with this recent approval, I think each Just product can set the benchmark of the standards that all of our other products for other companies can strive to achieve. So it provides a lot of clarity. So you know exactly what assays to run, what experiments to undertake, what testing to be done so that we can meet that standard instead of trying to do all sorts of experiments to try to convince the regulators that our products are safe.
Yeah, definitely. I think it's always nice to know that you're working very closely with the different agencies to see how you can be able to work closely with your innovation. And so hope to see more of your products out in the commercial. So really, looking forward to that. Probably next, I will jump on to Jung from BIFTEC. Looking through the whole Q&A session, there's a lot of questions asked about the postbiotics, whether what's the overweight, is there any chance to be overdosed? What are the allergies about for probiotics, and looking at is it possible for probiotics to assist in autoimmune disease as well? And lastly, they also like to know, can postbiotic be as a vaccine? So this is something that a lot of question on this. Probably I'll let Jung from BIFTEC to provide more insights and clarification on postbiotics.
Okay. So yeah, this is maybe if I share, can I share the screen at this point again?
Yes, please.
Okay. So for this, because there is one question in the regarding to the use of postbiotics in the different conditions. So this is so I'm going to answer these questions, but first of all, I should say now ask the immune diseases or the neurodegeneration, cancer, other kind of disease. Now these are as you see here, these are the metabolites, small chain fatty acids, vitamins, enzymes, teichoic acid peptides, and these actually have been shown to play an important role in the immune stimulation, cancer, to boost the immune system or the heart disease. These are actually, so for the questions that are asked from the audience saying whether or not this has anything to do with the vaccine, yes. Whether or not it's going to be used in the cancer, yes, but you have to try one by one those. Not all postbiotics have the same kind of effect in terms of their function for the cell or for the different cells. So you have to
one thing that you have to do is you have to do one by one in these conditions other than the muscle. So we are not doing research on any of these, but from literature you can see, that many reports, there are many papers that report the function of these postbiotics in different kind of conditions, both clinical and the research. So therefore, so I think this will answer some of the questions that have been asked. So yes, but you have to be very specific for what kind of, so there is not only one kind of postbiotic. So there is, consider that there are trillions of different kind of bacteria, the bacteria in our systems. So you have to isolate, you have to be very picky, or you have to set up your conditions so that you can use the one that is used. So one question related to using postbiotics in whether it's safe or not. Now, postbiotics, prebiotics have been considered safe by Food and Drug Administration in the United States for many years. So that's the one reason they call beneficiary bacteria. So they don't pose any, there is no risk of any kind of disease or any kind of conditions that may harm human health, and they are considered safe. So this is very important in our patent application also. So you don't need any further regulations for this, because already it has been, these postbiotics have been decided to be safe. So that's another question, another answer to the question from this Q&A answer. Someone, there is one person asked, the Biftex products taste like tofu or mushrooms, beef. Now, unlike other companies, we are at this point focusing on generating the cell culture growth supplement. So to make large amount of these meat for eating for commercial purpose, you need a very large bioreactors for this, which is tens of millions of dollars you have to spend. So you have to find a very strong investor for this purpose. But what we do is actually we generate muscle cells, we make muscle cells. So but we don't eat it. So at this point, but the taste is a cultural thing, as it has been presented in some of our speakers in this talk. So it needs certain kind of fat, it needs certain kind of scaffold and spices, that kind of stuff. So for example, in Turkey, the meat that I eat, you probably won't be able to eat in other parts of the earth or the world, or the vice versa. So it's just cultural. The meat itself doesn't have any taste at all. The ground beef, if you go to the market and get a ground beef with no fat and put it into the oven, the taste, if you don't add any salt or any spices, there is no taste. So the taste is something that you add. I'm not talking about the steak or other kind of pork chops or the other kind of structures, which is completely different area to generate. So I'm looking at the questions. I'm not.
I have another last question that probably is from the Q&A. So he was asking, do you have a database about the different types of post-probiotic that you have? And does it mean that it's very specific in terms of a different postbiotic is specific to a different cell line or stuff like this? And do you also include the plant bioactive into your formulation as well? So love to hear from you.
Okay, so if you remember the data that I show you, I picked up. So we used more than 60 different scaffolds on this, generated from this postbiotics. So these are, not every of them is useful in terms of the providing advantage for the cell growth. And if you remember the slide that I showed you, there are some notes saying that we name them different kind of letters and the numbers, and these are actually some cells. For example, we do these experiments in the cancer cells also, primary cells, cell line that is not cancerous cells. For example, we are using fibrotic cells from the hepatocyte cell. The hepatocytes are different kind of cells. So we have the different results. But once we have get the result, for example, let's say solution 1 is a very promising for muscle cell growth. So this is something that we take it and we do ex vivo experiments for this purposes. So not every postbiotics is good for every cells, but for the muscle cell, there are muscle cells or myocytes, there are a group of postbiotics every time that functions similarly. So that's with the once and now we are working on understanding, as I explain in my talk, we are trying to understand and characterize those much better, those postbiotics. So once we have done, the next thing we'll be using small generation of small molecules instead of them, and that just use the postbiotics again. So it's an area it's a very fertile area. You can go wherever you want, but for the answer for this question, muscle cells, there is a group of postbiotics. Cancer cells, there is a group of postbiotics. So these postbiotics, not every postbiotic is the same. So you have to, that's the reason we are working on it.
Yeah, really, thank you so much for all this in-depth clarification of what postbiotic is about. I do learn a lot as well, so thank you, John, for all these insights. Moving to next questions, we do have very generic questions asking about the difference between the cultured meat and plant-based protein, such as impossible meat. So probably I'll just ask the question to Mihail. What's your take on this? What is the difference between the cultured side and also versus the plant-based side?
Yeah, so I think, the plant-based side was an attempt to remove animals from the food chain with existing technology that could be commercialized right away. And so that involves using many of the foods we already eat, soy, many different grains, basically anything that was already in the food system, jackfruit, and combining it in ways that replicates the structure. If you go back far enough in the US, you could see Thanksgiving holiday tofurkey, which was literally just tofu shaped to look like a turkey. So from there, we've now come much closer to replicating the mouthfeel and the taste and the rest of the sensory aspects of animal-derived meats. And the goal of cultured meat is to sidestep some of those technical hurdles involved in the nutrition and the taste components that are sort of imposed by plants not being the same as animals, and use the cells that come from animals to produce something that biologically is quite similar to an actual meat cut from an animal. As was pointed out in the ants presentation, we don't need to replicate everything. Blood vessels are probably not the most important part of meat to get right, but we want to replicate it in a way that the nutritional profile, the flavor profile, and the actual biology of what you're eating are quite similar.
Yeah, definitely. I think this is always something that you can have cell-based in your plant-based product. So definitely there's a lot of ways that you can look into, and I always look forward to in the future what sort of plant and cell-based product we can find commercially. So that's something that I'm looking forward to it. Another question that I would like is, what is the biggest hurdle to sell cultured seafood? Because you're working on seafood sound line and looking at the different growth factors and media, and just asking why is it not extensively done to date? So we'd love to hear your point of view on these two questions.
Yeah, so I think if we look at just how animals are classified, not to get too deep into things, but cows, sheep, most animals that we eat are also mammals. And so many of these cells have been studied in one form or another as part of the livestock industry to help improve animal health, or have been studied peripherally to better understand human health. And so hundreds of cell lines have been developed and exist. Primary cultures exist in cell banks all around the world. And you can probably find a publication to answer many of the questions you might have to get started with how to grow the cells and what sort of markers to look for in understanding how the cells are behaving. Most of that does not exist for seafood because only maybe a dozen species worldwide are cultivated, are farmed in any meaningful quantity. And so if you're looking at trying to do cell-based salmon, for instance, or maybe even like a barramundi, there's probably cell lines available for these species because for the same reasons we're looking at their health, we're looking at how to make them grow faster on farms. But if you want to do something like bluefin tuna, like Finless Foods is doing, those cells don't exist, and it's probably been incredibly difficult for them to actually go get the cells in the first place because the fish are rare. And so I think in general, the lack of scientific sort of base to start from is one key challenge. And on the talent side, you then have to find people who are comfortable working in this very gray area of cells that they've never worked with before, and getting a whole team comfortable working on a new cell type. So I think these are some of the challenges that come from not having this wealth of scientific knowledge already built up.
Yeah, definitely. This is agreeable on site, and always hoping to see what sort of new research or innovation that can identify new cell lines, and also to see how we can create a better database of seafood. I guess that's something that I'm looking forward to as well. I know creating cell line is one of it. Another challenge is to get a scaffold. So the scaffold, we have to look at what sort of ingredients to do it. We have using plant-based material to create the scaffold. So there's a question regarding the scaffold. So what sort of plant-based material has shown the most promising in terms of achieving a scaffold? And then do you have any data on what kind of material is the most specific for different type of for different kind of cell line regarding on the scaffold as well? So I know Vin from Gaiafood also works on scaffold. Happy to hear from him what's his point of view on looking at plant-based material on scaffold.
Yeah, we are looking at plant-based, but it's not just a plant-based material. We are looking at any biopolymers, and we can functionalize them to be adapted for growth of animal cells. So yes, we started with the publicly available information that is like soy protein had been, textured soy protein had been shown as a material to grow cells, and they had shown some success and all in that aspect of it. But we are not stopping there. As I mentioned in our presentation, soya and tofu are all very common in Asian context. But if you give a tofu in a Western context, it will not run so easily. It will introduce certain amount of taste. Whether we like it or not, scaffold also gives some amount of background taste to it. So if we have too much of taste which is not suitable for a specific region, we run into the problem of meat looking like a foreign meat. So they don't accept it as the meat. So what we are developing is a platform, basically. You choose different biopolymers, and we can functionalize them based on your requirement, because you just can't take any plant material and put animal cells in that and start growing. They don't match up like that. It doesn't grow like that. So you have to put them in a condition wherein they support the growth of animal cells. If that was the case, we all will be hugging plants, and we should be able to integrate with that. Unfortunately, we don't do that, and that's where we are developing technology. I think it's the main thing is we are looking at a sustainable source. If there was any animal product which was sustainable, we will definitely be using animal products. Unfortunately, there are no animal-based scaffolds which can be produced on a sustainable level. That's the main issue. That's why we have to look for a plant-based material to grow these animal cells. But yes, soy is one of the predominantly studied, and we have a lot of data on that part of it. And safety-wise, it's pretty safe as well. But we are testing many other biopolymers in the meantime.
Yeah, I think that's really true. Looking at scaffold to be safe and then to give the texture, because it also provides the structure of the beef or the meat. I know you recently you also tried to create your own prototype on looking at cells and scaffold. I know taste, flavor, texture is very important for consumer, but I was wondering whether how are we going to convince consumer to switch from traditional form of meat to the cultured meat? And do you think that the cultured meat will be able to replace the entire of the farm meat industry? So Vin, I would love to hear this question. I know it's a huge question, but I always like to hear your point of view.
No, I think it's an upcoming technology. It's going to be there. It's going to address a major problem in our current way of producing meat. And it's like when cars and motor vehicles were introduced, people were still riding horses. But then if you'd ask them, like, do you completely replace horse riding? People would have told no, or things like that. Right now, we are literally replaced. But if you go to, there are you can still ride horses. It's not like there is no, but it's a hobby kind of a thing. Something like that. Cultured meat will take a significant portion in going forward. It's not like in 10 years, but much longer timeline. It will have a much bigger role to play. But of course, there will always be a certain amount of population of people who don't want to give up. And for them, fine, please go. Meaning, if you grow your own thing, and if you are like few hundred people out of billions of people, you can't do anything about them. But overall, I think this industry is going to change a significant portion of factory style farming industry. That's what we are focusing on. We are not focused on completely replacing animal farming, but factory style farming. That's the main target for us. Because if you have 10 cows in your backyard and 5 chicken and all, we are just go happy, enjoy your life. We have no problem with that. That's not the target also for us. We are looking at the factory reducing. First, we are going to target to reduce the burden of factory style farming, and eventually we will try to replace them going forward. And you can see the results also, because some of the biggest investors in this space are Tyson Food and Cargill and all. These are biggest meat producers in the world, and they are betting they are hedging their technology also. Like they don't want to be replaced completely. They don't want to be blindsided by this technology. So they are also putting money. They also know that this technology will have a significant role to play in the future. And yes, if you ride horse, yes, you can ride it as a hobby, but in general, it will have like cars will take over. The same thing happens with cultured meat also.
Yeah, definitely agree on this, because read a report before, they say that 60% of the meat is going to be made of alternative protein, and out of 60%, 35 will be cultured meat. So we do look forward to see what's the future like in terms of getting cultured meat, not just chicken, but look at even bovine meat as well. So really appreciate your answers to this. Next, I'll be jumping over to Su Jian and to ask you some questions. I think your slides have shown very interesting way of looking at meat strength, to how you can get everything together to achieve the fibrous texture of a meat. Just this question been asked is, so how do you bundle meat strength together? Is this a type of biotech process, or do you look at different ingredients to bind the different fibers together? Really happy to hear from you.
All right. So I think that question is related to how we envision the whole process of cultivating meat. So I think that based on our understanding and our take on what cultivated meat is, we see cells only as the flavoring, as contributing only the flavoring component. In that case, how we envision a meat cut to be produced would be to first culture the cells and to extract the flavor from it, and then move on to the next stage. The next stage would be entirely a food manufacturing stage. There will be no live cells. The cells would not be alive, and this would greatly reduce the complexity of the manufacturing process. So to answer the question, no, it will not be a biotech process. It will be more of a food manufacturing process in which we will be sourcing. In fact, we have been sourcing and testing multiple binders, and we're testing the binders for its biomimetic properties, which means how well its texture, its melting profile, its degradation rate mimics that of real meat and real meat connective tissue. And this would be entirely with no live cells, and is more of a food manufacturing structuring process.
Yeah, definitely. I do agree on this as well. I think food ingredients really comes in to help you do the binding to achieve the right texture in terms of the melting point, the chewiness of the product as well, to look at how you can gather all the meat strengths together. I know you have been working on your cell line to create a very good flavors, the meaty flavors that's required for your cultivated meat. So jumping next, there's also a lot of questions about fats, because fats comes out with a lot of the marbling issue, give you the texture, the flavors of what it is. So just like to hear, how do you incorporate this fat marbling into your cultured meat cuts? So really love to hear from you again.
Okay, yeah, so in line with the principles that I have laid out previously, once again, we think even for fat, not just for muscle, but also for fat, that the flavor comes from the cells, and the flavor can be incorporated using our very meaty cells. But the other components, like the oil, the triglycerides, the connective tissue, the structures of the adipocyte, structures to mimic the adipocytes in the fat. All this, we believe, can be replicated using plant-based ingredients and food manufacturing structuring process. For example, microfluidic processes, 3D printing processes. And this is also related to our tissue building block technology, in which we try to think about, in order to scale up, we need to be able to produce replicatable units of the meat so as to reduce the complexity of the meat structure. So we have produced the muscles, the tissue building blocks of the muscles would be strands that can be 3D printed as a filament, and the fat can be 3D printed as a hydrogel. So in order to replicate the intricate marbling, we will use 3D printing using the filaments of muscles and hydrogel, incorporating fats and cells as flavor to recreate the entire meat cut structure.
Yeah, got it. I mean, it's really interesting to see how many different elements that you have to create in to really create a product that has the fats component, the protein component, and also the fibrous texture that's required. I think that's a lot of things that we have to consider. Another question I would love to ask you is, do you think you create a product using cultivated cell as your base ingredient? How do you think our body can react to it? Do you think based on the hormones that we have or the digestive system, can it recognize that it's a cultured meat? And will we be able to digest all this, to absorb the nutrients? So there's something that we'd love to hear from you. And also, do you think there's any study done to show this absorption of the protein or the nutrients from having cultured meat as the food product?
Yeah, certainly. So I think perhaps we need to split this into two different types of products. Firstly, it's a 100% cell-based product, and the other is sort of our first product, which is primarily plant-based, but with cells added in. For the plant-based product, or for the hybrid product, since it's majority plant-based, the nutritional content and absorption and reactivity would be the same as a plant-based product. All that's changed is the flavor to make it a lot richer and meatier, to make it a much better plant-based product. For a 100% cell-based product, that we need to investigate whether or not the proteins have been changed during the culture process to cause any complications or difference in receptibility for the consumers. There are standardized procedures to test for this kind of bioavailability. And in fact, the Singapore Food Agency has laid out very stringent guidelines. So all this testing and experiments will need to be done with the data properly documented to be submitted to the regulatory authorities before the cultured meat product can actually be launched on the market. So if they think that it will cause any harm, it will not even be on the market in the first place.
Yeah, definitely. Regulatory is always there. And I think we having SFA as looking at the regulatory, I think I'm very assured that all the products that's created using cultivated meat, once they meet the regulatory standards, typically it's safe for consumption. But that's the last question I have to ask you based on the one of the question from the audience. They was asking you, how do you know or how do you plan to overcome the size limit posed by diffusion? So this is something that probably is very technical, and we'd love to hear from you again.
Okay. Yeah, I think this is related to my first answer to the question of whether the bundling of the strands is a biotech process. So let's say the bundling of the strands is indeed a biotech process. Then the cells, you need to ensure that the cells are not separated from the culture media by more than 200 micrometers, because anything more than that, the cells will not be able to obtain the oxygen, the nutrients for it to continue growing, and they will start dying off. So for our approach, we do not rely on a biotech process to turn cells into whole meat cuts. If we were culturing the whole meat cut and all the cells in the whole meat cut were alive at the point of harvest, then we need to think very hard about how do we have blood vessels inside to provide the cells with the nutrients that they need to grow. Yeah, and that is an immense tissue engineering challenge that we would hopefully like to avoid for making food. If we are growing this for implantation, for regenerative medicine, that is something we cannot avoid. But thankfully, we are producing meat that is mostly dead cells by the time it reaches the supermarket. So because the final product is mostly dead cells, we are able to first kill off the cell. We don't need the cells to be alive before we structure them into a larger construct. So in that case, we don't even need to think about the diffusion limits of tissue engineering.
Thank you so much for addressing all this different question on technical, looking at fat marbling, looking at your meat strength, even the diffusion on the particle size. So really appreciate your clarification and answer to this question. I have one last question I would like to ask Mihir, because I just like to hear your point of view again. I know that I'm just curious that we have a lot of innovation coming over these years and over the past few years. I would like to hear from you. What sort of next breakthrough innovation would you like to see in the cell-based industry, or even at the alternative protein space, which could be plant-based and cell-based together? So, what sort of a breakthrough innovation would you love to have in the market?
In the market or in the R&D?
In the whole industry, it can be anything. You can be the R&D, you can be your product, you can be your flavors, anything. We would love to hear what sort of breakthrough innovation you would like to see in the future.
Yeah, so I think I would like to see more products start to come out that are explicitly geared towards the average consumer. I think part of the imaging problem that cultured meat is going to have is if we're talking about making Wagyu beef, or we're making very specialty products because we know that our costs are currently high, then the messaging to the consumer is going to be that cultured meat is a luxury product, is an exclusive product. And I think it will take us time to then go and change that. So I think in some of our product reveals and the way that we present our technology, really describing how it can become a replacement for people who can't afford to pay more in the long term, will be important in setting the stage so that when the products come to market, people will be ready to buy them, right? They won't be thinking, oh, I can't afford that. That's not for me.
Yeah, that's true. I think the key thing is affordable. You have to make sure it's affordable, taste well, nutrition. So it's back to these vicious cycles. But then it seems easy, but there's a lot of different components you really have to think about, and also the innovation, the technology, and also have to think about scalability, because right now everything is in lab scale, and definitely one of the bigger hurdles is definitely to scale up the manufacturer to meet all the consumer demands. So really appreciate the angles that you're looking into. I'm very happy that we have 4 different startups companies here again that shares their company insights, talk about innovations as well. So before we really close this webinar or the seminar, I'd like to hear some closing statement from everyone here. So let's start with Prof. Zhang. What sort of closing statement you'd like to give everyone or the audience here?
Okay, so very briefly, I just make two very quick comments. What you have discussed so far. One thing about the use of the conventional production, whatever the jobs. According to the calculations, 10% of the whole meat production will be based on cultivated meat in 2030. So we are talking about something that is we probably see, but our grandchildren will see much better than us. So we are talking about a progressive event. But during these events, this technology will cause the formation of new jobs. So people, the people who are working on this area, new jobs will be formed, and that there will be many people who provide these ingredients for the using of this. So one thing that is, when we talk about is a concluding comment for me, when we say that the topic of this talk is hype or future, I think it is the future. It's not science fiction anymore. One thing that is, there are 2 important things for people who are going to use these cultivated meats from from 20 years now. One is there are tremendous amount of people who are vegetarian, who are other than the other concerns. They concern about, all of us concern about it, but they concern more, and that's the reason they don't eat most of the time. The majority, they don't eat meat because of the problems of the animal welfare. So that will not be a problem anymore. And the second one is there are some patients that they are not supposed to eat proteins too much. So in the future, maybe many people, considering the age of the earth, the world will be getting aged people, more aged people. So you would be able to manipulate and arrange the content of the meat. So for example, less protein for the people who has gut disease, for example, they don't need too much protein. For the people who have atherosclerosis, less fat, for example, less cholesterol, that kind of stuff. So these are very important. We are not, now the major concern at this point for me is the cost, but once we lower the cost, once this becomes more applicable, then we will see that this cultivated meat will be the solution for other questions as well.
Yeah, thank you so much, Prof. Gang, as this is really insightful. Next, moving to Vin from Guyaford, I would like to hear your concluding statement as well.
Yes, this is the up and coming technology, and absolutely is not a fad or anything. It is going to be there, and it will be much more pronounced in the coming future. And only thing, we'll take care of the technology. We will figure out how to bring down the cost. We'll figure out how to give the best tasting and best quality materials and all. But as a consumer or as a user of the technology, it's absolutely important to understand the technology. So give us opportunity anywhere possible. I will be happy to tell about this technology and explain you. Because at this point in time, whatever we all talk, it looks some very technical, like we are talking about FBS, we are talking about scaffold, all these kind of things may sound very technical. But when we break it down into individual components, it's much easier to understand. Then you feel more confident about it. The same thing, if you don't understand, please feel free to contact us. Or if there is an event, like we are happy to go to schools and colleges and to explain the technology. So that's the main thing. It's going to be there, whether we would like to eat it or not. That's the future. And be open to it and understand the technology rather than fight it. It will be good for our survival in the long term. That's as simple as that.
Yeah, thank you. Definitely education or even awareness of cell-based or cultivated meat is really important, especially for consumers. Exactly. Next, I'll hand over to Sun Jian to let me hear what's your closing statement as well.
Sure. Yeah, I think that cultivated meat is a really exciting field. For the first time, we are taking cells that we normally culture that for biomedical research, in which we have to, put the cells in biosafety cabinets, wear gloves to protect ourselves. But right now we are thinking of it as food and putting it out in our mouth. It's such an exciting field. And when I first tasted our pork cells, it just opens up so much imagination of the possibilities of this type of technology. But even so, like Vin mentioned, there's so many unknowns, so much that needs to be done, so much technology and innovation that's required to actually turn this into a commercially viable product that the masses can enjoy. That I think we need more passionate scientists to come into this field, both in the industry and also in academia. So I really hope that, as a young scientist myself, I really hope that young scientists and students that are really interested can find opportunities to join us for internships or come to the labs in A-Star and NUS and NTU to learn more about it and to really actively participate in this new field.
Yeah, thank you so much. I think it has a lot of chemistry between biotech and food science and technology. So these two cross together, I mean, there's whole new potential out there. So really excited to know that more, scientists or researchers, please do come into these different companies, ask them for some internship and to learn from them. But last but not least, Mihir, back to you again. I would like to hear your concluding statement.
Thank you. I think I'm always inspired to hear other people talk about their vision for the future and how we can use technology to make the world a better place. And to me, cultured meat stands out as one of the ways that we can do that, that can have massive, massive environmental benefits, can have benefits for human health, and can make the world a place that we can be really happy to live and thrive in into the long-term future. And I think that while there are many hurdles between where we are today and that future, it looks a lot closer now than it did 5 years ago. And I think that's the nature of these kinds of technologies, is whenever you look at it, it always looks like it's 20 years away until suddenly it doesn't. And I think we've just started cresting that point. And so I'm excited to be part of helping to bring this future into being, and hope that conversations like these can inspire people to see how they might be able to get involved in either the technology or even on the marketing side, helping us figure out what do consumers actually want to buy. How can we make sure that this technology doesn't die on the vine and that it actually makes it to the market and makes the impact we think it can? And I think beyond that, where we can go from here is limitless with these sorts of technologies. So if anybody is interested in having just conversations about how they can get involved, I would love to have those conversations, try to point people in the right directions, and help build a more robust food future for our planet.
Yeah, thank you so much. Even myself, I can't wait for the next 5 years. I have no idea what's going to be happening, but I do believe it's going to be an exciting journey from now to the next 5 years. So really appreciate 4 of you together, answering a lot of questions, clarification to all the question and answer from the panel or even the audience. So really appreciate your time. I'll hand it over to Jia again. Let her do the concluding statement. Back to you, Jia.
Thank you very much, Matthew, Mihir, Jan, Dean, and Chutin. It was a super interesting session, and I think the first panel I've attended, bringing together the different players in the cultured meat space specifically. So thank you once again. We have now come to the end of this session, Innovation Made Real, Future of Food. On behalf of NUS Enterprise and Big Ideas Ventures, we'd like to thank you for joining us. Do check out our other startup booths and events happening this week at Switch 2020. Thank you and see you again.
Thank you.
Thank you.
Thank you all.
Thank you.
Bye.